Hello everyone. Welcome to Business Analytics Series 1. Today we are going to learn one of the most important concept in business analytics, linear regression. Let's jump into that. So what regression does? Regression draws a best fit line through your data. It gives two things in return. It explains the strength and direction of the relationship. Today we are discussing linear regression. Linear regression takes one predictor and explains the variation in the other variable. In other words, it explains the variation in the dependent variable through the predictor variable. So let's learn how to do it in Excel. So here I am having the dataset containing store ID, advertising spend, foot traffic, store size, number of employees, average discount rate, competitor distance, and monthly sales. Let's go through one by one. Advertising spend is the actual expenditure on promoting the product. So the ad, whatever you're running on the social media or the TV or radio, that is covering the ad spend. Foot traffic, it indicates how many customers are visiting your store. That is the footfalls in your store. And we are having store size. It is actually the floor space or the square feet of that particular store. Number of employees, the employees working in that particular store. Average discount rate, that is on an average what is the discount rate charged by the storekeeper. Competitor distance, that is in kilometers, that is about how far your competitor retail store is located. So we are having 60 store data here, and we are going to conduct a linear regression. The study is all about the relationship between advertising spend and the monthly sales. So today we are going to discuss what is the impact of ad spend, or is there any impact of ad spend on the monthly sales. So my null hypothesis will be there is no significant impact of advertising spend on the monthly sales. My alternative hypothesis will be there is a significant impact of ad spend on the monthly sales. My test statistic will be linear regression model. So let's see how to do it in Excel. So before starting regression, we have to enable analysis tool pack. So we'll go to file option. In the file option, under options, we are having add-ins. So in this window, the left panel, you are having add-ins option. In the add-ins, you are having the bottom manage add-ins option is there. By default, it will be in Excel add-ins. If it is in other com add-ins, actions and all, just go to Excel add-ins and click on go option. You'll get this window. Here I have already enabled. So you have to just click on this checkbox analysis tool pack. It contains all the statistical tools and you have to click on OK. The moment you click on OK, either you have to restart the Excel file or this data analysis tool pack will be visible in the data tab in the ribbon, and at the right top corner you can see here data analysis. So this is how we can enable the analysis tool pack. Now to fit the regression equation, we will open the data analysis. Here you can see various statistical tools are already appearing. I will select the regression. I will click OK. So by default, you will be getting empty screen like this. You have to select what is Y range and X range. Y range indicate dependent variable, X range indicate independent variable. So I will take in my study the monthly sales are dependent variable. So Y range will be, I will take the column heading because in the output I want to locate these variables. So I will take monthly sales, that is H1 cell. I will use shift and control button to reach the bottom of the data set. So H1 to H61 will be my dependent variable range. Independent, as per my hypothesis, ad spend is my independent variable. So I will select B1 cell, shift control down arrow. So B1 to B61 will be my independent variable. Since I have selected column headings, I will click on these labels. Otherwise, regression will not work. It will include the first row as well. Since first row is having text items, regression will not run because text function are not valid data for the regression. It takes only numerical values. So I have to click on labels. I will keep the new worksheet as it is because I want to see the output in the new sheet. If you want the output in the same sheet, you can click on output range and you can click on this white box, enable the text cell here, and you can click any of these empty place where you want to get the result. Since I am going with the new worksheet, I will not select this. I will click on new worksheet. I will click OK. So here you can see I got the output, multiple R, the R square, all the regression statistics, ANOVA table. I will just expand these values. ANOVA table and as well as coefficient and its parameters or p-values. So let's analyze one by one. Start with multiple R. Multiple R indicates the correlation and its direction. The correlation between ad spend and the monthly sales. Here we can see 0.77, almost 70%, that is a correlation between ad spend. Since the coefficient since it is positive value, we can say it is the positive correlation between the ad spend and the monthly sales. Next one is R square. It indicates the variation in dependent variable explained by independent variable. In this scenario, 60% variation in monthly sales are explained by independent variable, that is ad spend. 60% is a good number, still 40% is unexplained or not explained by ad spend. Next one, adjusted R square. It adjusts the R square value based on number of predictors. In this scenario, we are having only one predictor or one independent variable. That's why the values are almost similar. The adjusted R square and R square value is almost same. Next parameter is standard error. The standard error, we are having 2.54. Since monthly sales was in lakhs, we are having 2.54 lakhs, or we can say the error, standard error, the variation in residual error. Before explaining this, I will explain what is residual. When you fit the regression, it predicts the sales based on the advertisement, based on this regression coefficient and the intercept, or slope and intercept. It predicts the sales for the given dataset. Then it compares actual monthly sales with the predicted monthly sales for the given dataset or for the 60 stores. In between, there will be variation. Actual sales minus the predicted sales, you will get the variation. That we are calling it as residual error. The standard deviation of that residual error is this standard error. So we are having a typical distance between store's actual sales and the line, or we can say the regression line, that is almost 2.54 lakhs. Smaller the error, better the regression fit. That is the parameter. Next one, the observation. Since we had 60 stores, so our observation is 60. Next ANOVA table we have seen. In this, the F statistics, we got 87.1. It tests the model as a whole against the variation that is not explained by ad spend or the independent variable. So here we are going to study, is this model a good fit? Is it a good fit to forecast the monthly sales based on ad spend? Since it is 87.1, apart from that, since it is 87.1, we are having a larger number. Apart from that, we are having a p-value, that is significance of almost equal to 0. So 3.76 E-13 means after 13 zeros, you are going to have 376. So it's almost equal to 0 and lesser than 0.05. That means it is statistically significant. Let's move on to the intercept. The intercept is 10.46 and its p-value is 1.43e, which is almost equal to 0. The coefficient 10.4614, the intercept indicates when you don't spend in advertisement, when ad spend is 0, the variation in the sales. So when you don't spend anything in ad spend, because of other influences, the sales will increase by 10.46 since it was in lakhs, so 10.46 lakhs. That's what the intercept indicates. So where the line meets y-axis, that means the sales the model predicts when ad spend is 0, it anchors the equation at 10.46. Means if you don't spend anything in ad, then you'll be having increase in sales with because of other factors 10.46 lakhs. Moving on to the next item is slope of the regression, or we can say the coefficient. We're having ad spend as the slope or independent variable. This explains the changes in the sales because of the ad spend. Here we are having coefficient 0.105 and p-value 3.76e-13. That means it's almost equal to 0. That in other words, it is lesser than 0.05. In hypothesis testing, we are having a decision rule. If the p-value of the coefficient, if it is lesser than 0.05, we reject the null hypothesis. If it is more than 0.05, we accept the null hypothesis. Rejecting null hypothesis means we are going to conclude that there is significant impact of ad spend on the sales. Accepting null hypothesis means there is no significant impact of ad spend on the sales. So since it is lesser than 0.05, we can conclude that model is significant. Now what is the interpretation of this 0.105? What does 0.105 indicate? If you know the data set earlier, the ad spend was in 1000, the monthly sales was in lakhs. If you spend 1 unit more in advertisement, the sales will be 0.105. Here 1 unit of ad spend means 1000. 0.105, if we convert them into lakhs, then it will be almost 10,522. So 1000 additional expenditure in advertisement will lead to increase in sales or to the amount of 10,500 rupees. So there is no increase, 10,500 will be the sales amount. So I will explain again. If you spend 1000 extra in advertisement, sales will be 10,522 rupees. That's what this slope indicates. Since the p-value is lesser than 0.05, the model is significant. The regression equation is sales equal to 10.46 plus 0.105 into ad spend. So based on this equation, if you know how much you are going to spend in advertisement, you can estimate the monthly sales of the company. Let's assume if you are going to spend around 80k in your advertisement, suppose 80,000 if you are going to spend in advertisement, then your sales will be around 18.88 lakhs. Again, the 80k I have to divide it by 1000 since ad spend was in 1000 in my regression equation. So that will be ultimately 80. So it will be around 18.88. Again, we have to convert it into lakhs because answer is in sales. Sales we have taken in lakhs in the data set. So 18.88 lakhs. So this is how we can use regression equation or linear regression to predict the sales. That's all about linear regression. I hope you have understood how to fit linear regression in Excel. In upcoming video, we will be learning how to fit a multiple regression model. If you like this content, do like the video, subscribe my channel AD Analytics. Thanks for watching.